All right, good morning. Welcome to section 9.3, polar and rectangular coordinates. So I'm going to break this into two parts. So this is part one here, and then I will post part two later today as well. So polar and rectangular coordinates, basically we're going to convert back and forth between the two. So how do we get from a polar coordinate plane to a rectangular, our traditional XY coordinate plane? And then how do we go from XY back to polar? So that's going to be the main focus of this section. Polar coordinates, are in r and theta. So we have a radius, a distance from the pole on the polar graph. That's the circular graph. So that's how many rings out we are with r radius. And theta is the angle, whether it's in degrees or radians. And in rectangular form, we use x and y. We can change back and forth from one to the other. So if we imagine the point 3 pi over 4 in polar, how can we write that in rectangular? That's kind of what we're going to. Or if we have the point 5, 6 in rectangular, how do we get back to polar? So that's what we're going to show you here in the upcoming slides. All right, so if we're going from polar to rectangular, so we're on the polar coordinate plane, we want to get that back to the rectangular coordinate plane. The way we get x and y is to do r cosine theta. So we'll be given a polar point. So we'll have the r value, we'll have the theta value. We will take r times the cosine of theta, that will give us our x value. R times the sine of theta will give us our y value. And we're going to do two examples of that. You'll see that'll be on the next slide. So one is in degrees, one's in radians. That's okay, we still do it the same way. The only difference here is you got to make sure your calculator is in the right mode. So again, work for this is on the next slide, but we're going to change 3 and 270 degrees and -2 and -5 pi over 6 from polar coordinates to rectangular. And so here's the work for that. We'll start with the first one here, 3, 270. So for x, 3 times the cosine of 270. The cosine of 270 is 0. I got that. You can get that from your unit circle or from your calculator. 3 times 0 is obviously 0. Then we're going to do the y value. So our y value is our sine theta. So 3 times the sine of 270. So that is 3 times -1 or -3. So our rectangular coordinate point is 0, -3. So 0, -3 is the same as 3, 270 in polar. Our second example, this one's in radians. That's okay. We do the same way, use the calculator. So -2 cosine of -5 pi over 6. And you can type it in the calculator just like that. It'll give you a decimal. That's fine. In this case, that's -square root of 3 over 2 if we use the exact value. So negative times a negative is a positive. So this is the square root of 3. As a decimal, it's like 1.71. And again, decimal is fine for that. So if you said x was 1.71, we're good with that. Then the y value, -2 times the sine of this radian value. Sine of -5 pi over 6 is -1/2. So -2 times -1/2 is 1. So again, the rectangular coordinate for that polar point is square root of 3, 1, or again, if you're in decimal, 1.71 and 1. Again, just one more example here, and I'll show you the answer at the bottom will be in exact and in decimal form. So again, here's our r and theta value. So 3 cosine of pi over 4, 3 sine of pi over 4. We know pi over 4, that's 45 degrees, so sine and cosine are the same. They're both square root of 2 over 2, which is like 0.71. So 3 times square root of 2 over 2, and same thing here for y. So here's the exact answer if you did it that way. Otherwise, if you did the decimal version, which is fine, then you're going to get 2.12 and 2.12. So x and y are the same, and again, that's because we're at 45 degrees. So the point 2.12 is the same as the point 3 pi over 4. One last one here, and again, just using, you can use the calculator or use the exact values from your unit circle, it's fine. Pi over 3, that's 60 degrees. So 5 cosine of pi over 3. Cosine of pi over 3 is a half, so 5 times a half is 2.5. Sine of pi over 3 is square root of 3 over 2. And so 5 times that as a decimal is 4.33. So 2.5 and 4.33. So again, just want to point out, with these problems, you can write them in exact form or decimal form. So if you wrote it in exact form, it would be 5 halves and 5 square root of 3 over 2. Most of us, myself included, will go with the decimal version, so 2.5 and 4.33. Last slide here for part 1 of section 9.3. So this one's back in degree form again. So we got an R value of 11. So if you think of the polar, the circular grid, that's going to be way out on the 11th ring, and we're at 75 degrees. So we could draw a picture of this, but really it's not necessary to write a polar graph or draw a polar graph all the way out to the 11th ring. We can just do the calculation. So for our R value there, and I see I missed the negative. My apologies right there. It should be negative 11. Sorry about that. So negative 11 and 75 degrees. So negative 11 cosine 75, according to our calculator, is negative 2.85. And negative 11 sine of 75, negative 10.63. So again, here's our decimal version of that coordinate. If you could try to get them into exact, but there's no need to do that since your calculator is going to give it decimal mode anyway, so we'll just do it this way. So this point, if we were to go 75 degrees from 0 and 11 rings out, that would be the same as this point, which is going to be in third quadrant. Why third quadrant? Because we have this negative R value here. So if you think about going up to 75 degrees, you're in first quadrant, and then you got to go negative 11, which is 180 degrees back the other way. So again, that's our last example for today. That will conclude part 1 for 9.3.